Welcome friends. In this video we are going to discuss complex number and we will focus this chapter for IB Maths AAHL. So let us see first what is the complex number. So if any number is written in the form of x plus iy where x and y are real number. What are x and what are y? X and y should belongs to real number, and what is this I? And there is a condition that I square should be equals to minus of 1. So if any number is represented in this form, so that is the complex number. And we can represent this complex number by z, and this is z is equal to x plus iy. So z is the collection of all complex number. In practically we can say all numbers are complex number, right? How? We will see very soon. Now the next important concept is conjugate of complex number. Let us see what is the conjugate of complex number. So this is a very important conjugate of a complex number. First of all, how we represent this? So conjugate of complex number is represented by z bar, and what it is? So if z is x plus iy, so its conjugate will be x minus I of y. What we have to do? We have to complement the sign of its imaginary part. See, this is the real part in which there is no I. So this will be called as real part, and this will be called as its imaginary part in which there will be I. So to get the conjugate of complex number, what we have to do? We have to complement the sign of imaginary part. If it is positive, you have to do it negative. If it is negative, we have to do it into positive. So that's the conjugate. Next, if we do two times of conjugate, let us suppose z is a number, we have taken its conjugate. If we do again conjugate of this, and it means conjugate of conjugate, so we will get the same number. For example, if z is equals to x plus iy, so z conjugate will be x minus of iy. So again, if we take the conjugate, we will again get it x plus iy, which is basically original z. So that's the property also. So now how we can represent this complex number z and this conjugate of z. So next we are going to see their representation. Representation of complex number z. So there are many ways. The first way is in order pair. If we want to represent it in order pair, so how we can write? See, if z is equals to x plus iy, we can represent it in x comma y like a coordinate system. The first point will be its real part, and the second part will be its imaginary part like coordinate system. And for the representation here, we have Argand plane, not Cartesian plane. So this is the imaginary axis, this is the real axis, and this plane is called Argand plane. So where will be x and y? So on the real axis, you have to go x units, and in the imaginary axis, you have to go y units. So this point will be z, and which can be represented as x comma y. So this is the first form, that is in order pair. The next is as a vector. As a vector, we can also represent this as a vector. See, let us suppose z is equals to x plus iy. See, previously we get that if this is the real axis, if this is the imaginary axis, right? And so this will be x unit, and this will be your y unit, and this is the point z. So we can represent this z, this point z, we can We can identify this point z via vector also. If we draw a straight line like a vector from origin to point z, and if we know the length of this vector and the inclination with x-axis, that is the slope, so we can also represent z in this manner. So this is called the vector form. So what we need to represent this, the length of this vector, let us suppose this is the r vector, so length of this vector and this angle theta. So this can be represented as r and at the angle of theta. What is the r? R is the length of the vector, theta is the angle with the x-axis, or you can say slope. So what we can say here? Here we can say the position vector. The position vector OZ, or we can say here its name P point. So the position vector OP, it's better to write OP, represent complex number Z, right? So this is the vector form. Next, how we can represent conjugate of a complex number. So next we are going to see representation of Z conjugate. See, that's the very important. See, let us suppose we have a complex number Z is equals to x plus iy. So let's suppose this is the point Z, x comma y. So what will be its conjugate? Its conjugate will be Z bar is equals to x minus iy. In order pair, if we want to write, we can write x comma minus y. Its x coordinate will be same, so its x coordinate will be same along this line. Its y coordinate is negative of y, so it is going straight downward. So this is x comma minus of y, and this is the z conjugate. What does it mean? It means that to get the conjugate, we have to take the mirror image with respect to take the mirror image with respect to real axis, not the x-axis. Here we can say real axis. Take the mirror image of point with respect to real axis, right? So this is the very important. So we can write here z and z conjugate are mirror image to each other with respect to real axis, and at the end, this is Argand plane, not a Cartesian plane. In this short video, I have mainly focused what's the complex number, its representation, its conjugate of complex number.